Audio Jungle. Audio Jungle.
This oblique plane is what, like this. Check. This is the oblique plane. Okay. And for this oblique plane, we had calculated that normal stress as well as shear stress over this oblique plane. All right. And we had calculated that value. This was sigma n normal stress, and this was the tau shear stress. All right. So here you had seen that angle was theta, and for this angle you had calculated this normal plane and this normal stress, and this normal stress was on that inclined plane, or sometimes called oblique plane. And that formula, again I want to write this. It was sigma x sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. This was the normal stress on the oblique plane. And what is the shear stress you had calculated in last class? It was sigma x minus sigma y by 2. And here this is the multiplication. I think in previous lecture I had made mistake. It was plus, but it should be product only. Minus tau xy cos 2 theta. Okay, this was the formula. Now before entering into principal stress and strain, principal plane and all, one thing we want to discuss here, like we have normal stress, right? This is the normal stress, but can we get what is the maximum condition normal stress? For this normal stress, what is the condition for maximum value of the normal stress, or where the maximum stress will be existing? What is the plane? Before entering in principal plane, principal stress, we should go for this calculation. So here you are going for this normal stress, and you are going to achieve that condition where this normal stress will be maximum. And if it is maximum, then what will be the condition? Okay, what will be the value? What will be the orientation? That is the job you are going to do here. Okay, then we'll talk about the principal stress, major and minor. First we'll go for the location of planes of maximum stress. Okay, so here we are going for the location of planes of maximum stress. So before entering into that, we have the sigma n, and we know to maximize the function or to minimize the function, what is the condition? So condition is very simple. We have to differentiate this. Okay, so what we have, sigma n, this sigma n, if we want to achieve sigma n max, then we have to differentiate this sigma, and we have to differentiate with respect to theta, because we are interested to achieve the plane. Okay, what is the location of plane? So location of plane, that means it is they are talking about the theta. What is the orientation? So dou sigma n by dou theta. Theta is the obliquity, which is also called angle, that is the angle from the vertical plane, and this should be equal to 0. If you differentiate with respect to theta and make it equal to 0, then this condition will be called as a maximum condition. To maximize any function, you just first derivative and make it equal to 0. That means slope equal to 0, and where the slope is 0, that means you are achieving the maximum condition. And same thing for the minimum condition also. Okay, so now, so only steps I will write, because differentiation you do by your own. So you have sigma x sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta tau xy sin 2 theta. You just differentiate this with respect to theta and make it equal to 0. If you do this, then what value you will get? See, this part will be, first part will be 0, second part it is cos 2 theta, so it will be minus sin 2 theta into 2. Okay, this is tau xy, and this sin 2 theta differentiation with respect to theta will be cos 2 theta into 2. So you do it and make it equal to 0. Then finally what you will get? You will get tan 2 theta. Tan 2 theta is equal to 2 tau x divided by sigma x minus sigma y. Okay, this value you will get. So first thing, this is for 1 marks. Like if question will be asked, what is the location of the plane of maximum stress? Maximum stress for what? Maximum stress for normal we are talking. For normal stress we are talking. Normal stress. Okay, so what will be the location of this? So it is nothing but theta is equal to it is nothing but 1 by 2 tan inverse 2 tau xy. This is the orientation. So this is for 1 marks, you need to remember. Okay, so this is the location. And if you talk about this location, so what is the mean of it? I mean, if you go for the normal stress, so this normal stress we will get where that normal stress will be maximum, and that angle we got here, and that angle we got here, and with this angle we can achieve the plane where the stresses will be normal stresses will be maximum. Okay, so now based on this we have to talk about the principal plane. Okay, so what is the mean of the principal plane? So principal plane is basically uh, in general, if you check here, a body may be acted upon by direct stress and shear stress, just like a oblique plane you have seen. And however, it will be seen the even in such complex system of loading. Okay, like if you go for this stress system, so it was like what? It was like this: sigma x, sigma y, okay, sigma x and sigma y, and for this oblique plane you are calculating that value. Okay, here this one. So there exists a mutually perpendicular planes on each of which the resultant stress is wholly normal. Okay, so these two planes called as a principal planes, and the normal stress across the planes called as a principal stresses. Okay, for this we have orientation, that theta we have calculated here. See, this theta value we have calculated here. So the larger value of two stresses, because if you are talking about the sigma n, this value you achieve, theta you have calculated here. So it is the orientation. Okay, it is the orientation. So larger value of the stresses called major principal stress, and the smaller value will be called as a minor principal stress. That value will calculate, don't worry. And the corresponding plane will be called as a major and minor planes, where you are getting maximum normal stress value. That will be called as a major principal stress, and where you are getting minimum value of this normal stress, that will be called as a minor principal stress. As I told you, if you want to differentiate and make it equal to 0 with respect to theta, so that will be the condition for maximum, and the same condition you will get for the minimum. Okay, so for maximum and minimum both you will achieve when you are differentiating it with respect to theta and make it equal to 0. So whatever the theta value you will get, one theta value will give the maximum value, another, just if you add 90 degree with another plane, so that value will, you may have a minimum value. So maximum and minimum both you will achieve with respect to this evaluation, like dou sigma n by dou theta you are making it equal to 0. So this is the condition for maximum and minimum both. So whatever the theta value you are achieving, one theta value will give the maximum value, another theta value if you add with 90 degrees, so another plane you will get, and that theta value will give the minimum value. Okay, that will calculate. That is the one thing about the principal stresses. Now here if you check in this calculation, whatever the value of theta you have calculated, for this it will draw the plane here. So plane I will draw, then it will be more clear to you. So the principal plane, what is the mean of the principal plane, or what is uh, the normal stress across the principal plane is the principal stresses, as I mentioned. So if you talk about the principal plane, so let me write this, the principal plane, then I will show you with the angle. So this is what principal planes. So principal plane, the plane on which only principal, the plane on which only normal stress will be acting. Number one, if I say only normal stress, then what about the shear stress? So that means the plane, this is for 1 marks, you remember it. Okay, the plane on which shear stress is 0. Okay, shear stress is 0, called principal plane. Okay, if, third point, if shear stress is 0, if shear stress is 0 on plane, on a plane, on the perpendicular, principal plane, on the perpendicular plane also shear stress is 0. Simple. Okay, now to locate principal plane, assuming principal plane is making an angle with the vertical plane, I'm talking about the principal plane. Okay, so just forget about the theta, now we are talking about the principal plane. So I'm assuming that principal plane is what making angle alpha from the vertical. So one diagram I will draw, so it will be more clear. So better I will draw here. So I'm considering, so here you can check where is the principal plane, it will be very easy now. So I'm considering this is the bar. Okay, for this bar, suppose the stresses are acting, this is what sigma x, so obviously here also we have sigma x or sigma xx, that meaning will be same, and here this value will be what, sigma y, this is what tau xy, this is the stress system. Now I just want to show you that I'm assuming, because I want to locate that principal plane. So where will be the principal plane? So I'm considering from the vertical, that principal plane is what making angle alpha. Okay, here. Suppose this is the principal plane. I'm assuming this is the principal plane and this is making angle alpha from the vertical. So this is the one principal plane. There will be one more principal plane, okay, and that principal plane will be with 90-degree away from this principal plane. So here this is the another principal plane. Just say this principal plane is nothing but called major principal plane. This is the major principal plane. Major principal plane. So this will be called as minor principal plane. As I told you, on the principal plane, two principal plane you will have, major and minor. Major and minor. Here you will get maximum principal stress. On this plane, whatever the stress you will get, it will be called as a principal stress. First you should know what is the principal plane, and this is minor will be minimum, the plane on which only normal stress will be acting. So here on this plane and as well as this plane we have only normal stress. So this normal stress, as I have shown you, differentiated and make it equal to 0. So we'll get two normal stress. Two normal stress we will get. One will be called maximum normal stress, and this another will be minimum normal stress. Okay, maximum normal stress and minimum normal stress. So basically sigma n is what now divided in two part, sigma 1 and sigma 2. Okay, sigma n is what divided in two part, maximum will be sigma 1 and minimum will be denoted by sigma 2. So here also, so on principal plane, like only normal stress will be acting. So that normal stress, how many normal stress you what are the classification for normal stress? Two. One is maximum normal stress, another is minimum normal stress. So where the maximum normal stress will be acting on that plane will be denoted by sigma n and it will be sigma 2. Okay, right. Second point is the plane on which shear stress is 0. So it is very clear here the tau value will be 0. Okay, tau value will be 0, that shear stress will be 0. So you can say it is tau, this value will be 0, and here also tau will be 0. It is clearly mentioned if shear stress is 0 on a plane, on the perpendicular plane also shear stress is 0. The perpendicular means this is. So on both planes. Why? Because the principal plane is what? Where the shear stress becomes 0, and now the principal plane we have a 2. Why 2? Because normal stress is what divided in two part. One is maximum normal stress, another is minor normal stress. That maximum normal stress called as a maximum principal stress, and minimum normal stress will be called as a minimum principal stress. Okay, so and it is very clear on principal plane shear stress 0, hence both planes we have shear stress equal to 0, right? All right, now so this where the value where the major principal stress we have, this is called sigma 1, and where the minor principal stress we have, this is called sigma 2. So minimum minor principal stress also called minimum principal stress, and this principal stress where you are achieving from the normal stress. Okay, that you need to remember. That is the very important point here. You got this. Okay, so now as we have the formula for the uh, orientation of this principal plane. That orientation you achieve like theta value here. So we had calculated shear stress. So tau we had calculated. What was the value of tau? So tau on oblique plane, it was sigma x minus sigma y by 2 sine 2 theta minus tau xy cos 2 theta. So for this shear stress tau, if we want to maximize this tau value, then what we'll do? Simple, like we had done for the normal stress. What we'll do here? We have to differentiate this and make it equal to 0. So we'll have to write here. So location of maximum shear stress, and it is also called shear plane. They are asking in exam. So how to achieve the shear plane, and what is the mean of the shear plane? So shear plane, need to write here what is the shear plane. So shear plane is the plane where the maximum stress is what acting, called shear plane. Okay, where the maximum shear stress is what acting, called shear plane. At shear plane we have maximum shear stress. Point number 1. Point number 2 for the shear plane is the angle between any principal plane and nearest shear plane is 45 degree. Okay, angle between shear plane and, I will show you how. Principal plane is this one, you need to remember. Okay, they are asking in exam 45 degree. I will show you. So how to get location? Simple, dou tau divided by dou theta, make it equal to 0. If you differentiate and make it equal to 0, so sine 2 theta will be what? Cos 2 theta into 2. Similarly, cos 2 theta differentiation is sine 2 theta into 2, and you solve it, then you will get tan 2 theta here. This tan 2 theta, if you solve, then what value you will achieve? It's a simple only, simple derivation. You can do by your own also. So it is nothing but sigma x minus sigma y divided by 2 tau xy. This is the value of tan 2 theta. Let me keep this in bracket. This is what for the SP, shear plane. Okay, it is for the shear plane, SP.
Sir, can you explain it?
Anyway, so so you have been seen here principal plane and shear plane. So for the principal plane where normal stress was maximum, and shear plane where shear stress is not maximum. So we have principal plane here. See, this is for 1 marks question, so please write properly. And this is what? Shear plane, where you will achieve principal plane, where normal stress is what? Maximum. Where you will achieve shear plane, where shear stress is what? Maximum. The normal stress, it is maximum, hence we have two stresses, normal stresses called sigma 1 and sigma 2. This sigma 1 was called major principal stress, and this is called minor principal stress. Then you got orientation of this. What was that? Tan 2 theta for the normal, for the principal plane I'm saying. So it was 2 times of tau xy sigma x minus sigma y. So here if you go for the plane, which is first plane, which is nothing but theta p1, so theta p1 will be 1 by 2 tan inverse 2 tau xy sigma x minus sigma y. And what is the theta p2? I mean second plane. Second plane is nothing but minor principal plane, and for the minor principal plane it is orientation is theta p2. Major principal plane orientation is what? Theta p1. Hope you understood. So what is the theta p2? It is theta p1 plus 90 degree. All right, this is the one thing. What about the shear plane? So I explained, like, shear plane is the plane where maximum shear stress will be existing. Okay, that point I had written, and I also mentioned angle between that principal plane and shear plane will be 45 degrees, so that I will show you. So two planes you will have. Okay, for the shear plane also 2 planes you will have, and both planes are at perpendicular angle. Okay, so now we'll find the orientation for this. So shear plane, like previous we had seen the shear plane orientation, and we had calculated it is shear plane, hence this is called shear plane. So because of the shear plane S, this is P. Why? Because principal plane. Okay, this is PP. So this orientation is P only, that means principal plane orientation. This is S, that means shear plane orientation. You had seen it was sigma x minus sigma y 2 tau xy minus, you had seen previously. I can say this is the slope, tan 2 theta is nothing but slope. This is what m2, and you achieve here sigma x minus sigma y 2 times tau xy minus 1, and this was the tan theta p1. This is what the m1. Okay, now from both slope, because tan theta is the slope, but we have tan 2 theta here. Anyway, if we have tan 2 theta also, no problem. So what is the idea behind this, giving this m1 and m2? Why we are talking this slope and all? Because if you go for this, then you may see that orientation or that angle between these two, what you will achieve. See, if you check m1 into m2, what is the m1 into m2? M1 is nothing but check, m1 is nothing but 2 tau xy 2 tau xy sigma x minus sigma y into what is the m2? Principal plane, which is nothing but sigma x minus sigma y by 2 tau xy. Minus sign we have, we can take minus sign. So it is what? cancel out, it will be -1. So two slopes product you are getting -1. So that always indicates it's a perpendicular. But the condition is we have, instead of m1 m2, that is the slope, but that slope we have what? It is 2 theta, not theta. It, because slope is what? Tan theta, but we have tan 2 theta. So we can say, if you go for this, then we have a 2 theta is equal to 90 degree. Yeah. So what is the theta? Theta will be what? 45. Huh? So what is the mean of it? Mean is, because the slope was tan 2 theta for both, so if you multiply this, then m1 into m2, if you are getting -1, that it is perpendicular. But if you calculate the angle, then what will be the angle here? 2 theta. Why I am saying 2 theta? Because if you check, it is tan 2 theta. It is not tan theta, it is tan 2 theta. Similarly here also it is tan 2 theta, not tan theta. So but slope is what? Tan theta. So we have 2 theta. For that reason, if only theta we have, then it is perpendicular. Perpendicular means theta is what? 90 degree. That you know. But because that angle is what? 2 theta, hence it becomes 2 theta is equal to 90 and theta is equal to 45. So what is the mean of it? If theta is what? 45, then its mean is the principal plane. Planes, or plane you can say, because two principal planes we have. So principal planes and shear planes are placed away by 40 degree. This is for 1 marks, you always remember this. Okay, so the angle between any principal plane, we have two principal plane, major and minor. Similarly shear plane also we have two. How we can get, we can say two we have? See, by this only, by this calculation, if you calculate, so theta s, you may have theta s1, and that value will be what? 1 by 2 tan inverse, it will be sigma x minus sigma y by 2 tau xy, and this is that 2 minus, what is the theta s2? Theta s2 is nothing but theta s1 plus 90 degree. Okay, so two shear plane we have, just like a principal plane we have two. But if you talk about the principal plane and shear plane both, so they are separated, or the angle between any principal plane and nearest shear plane will be 45 degree. I will show the diagram, then it will be more clear to you. This is the block. Sigma x, sigma x, sigma y, tau xy, tau xy. Now we are interested about the shear plane. So principal plane. So I can say what were the principal plane we have here. It is separated by 45 degree. So I would take this one better. I will draw here. This is the principal plane, you can say here. This is the principal plane, and this angle you may say it is theta or alpha, whatever you can take, So this is the principal plane. So this principal plane will be first one, P1, and orientation wise it is theta P1. Another will be, this is what? Minor plane. This is what? Major plane. If you talk about the shear plane, so where will be the shear plane? So shear plane will be exactly at 45 degree. I must draw here. So between this major plane, this angle is what? 45. and perpendicular to this shear plane also we have Arey Maharaj. No, fine. So this angle is what, 45. So this and this are 90 degree. Okay. So this is the shear plane. So nearest shear plane for this principal plane is what, away from 45 degree. Similarly, this principal plane and this principal plane is also away from 45 degree. This is also called shear plane. Okay. At the shear plane, tau max will exist. At the principal plane, obviously sigma and max will exist. At the same time, here on shear plane, shear stress will be 0. This is all about the principal plane and shear plane. Now we'll calculate the value of principal planes. So how to get that? It's a simple. Now I will do the manipulation. So just give me time. So here you have written sigma 1. This sigma 1 is nothing but plus okay. This is the value in root. If I say what is sigma 1 minus sigma 2, okay, I will get some exclusive result. For that reason I'm doing. So if you subtract these two, so this first sigma x plus sigma y by 2 and sigma x plus this will be cancelled out, and this will be plus and this is the minus, but if you subtract this, then minus minus will be plus, so it will be added both. So what value you will get? You will get 2 times sigma x minus sigma y by 2 plus because this 2 will be added 2 times. What is the sigma x minus sigma by 2 whole square plus tau x square, and it is in root. What is this value? This value will be sigma 1 minus sigma 2 by 2. What is this value? It is nothing but, check here, it is nothing but tau max. See, sigma x minus sigma y by 2 whole square plus tau x y whole square, and this is nothing but tau max if you check the value. So whatever you achieve, this is nothing but tau max. So this is also very important. Okay, in competition they are asking, they will say, they will give the principal stress major and minor. Sigma 1 and sigma 2 is what? Major and minor principal stresses. They will give this value and they will not give sigma x sigma y, they will not give tau x y, only sigma 1 and sigma 2 you will have, and they will ask what is the tau max. If you know this formula, then easily you can calculate. Only sigma 1 minus sigma 2 by 2, that will be the value of maximum shear stress. Please remember, this is very powerful formula. In one day exam, very frequently this question they are this based on this formula they are asking question. Okay, because most of students remember this formula, and they will, if they ask tau max, then they will search where is sigma x, where is sigma y, where is tau xy. But unfortunately they will not give this value, they will give sigma 1 and sigma 2. So what they will do, with the help of this sigma 1 sigma 2, they will try to get sigma x and sigma y tau x. So it will be very difficult and it is kind of impossible things in exam. Better you remember this formula, so tau max you can achieve. So further we will have few discussion 5-10 minutes, but we'll do in next class. Thank you.